Picture a sky so thick with ash that daylight vanishes for months. Crops wither, temperatures plummet, and societies teeter on the edge of collapse, all because of a single volcanic eruption halfway across the globe. This isn't science fiction. It's the chilling reality of how Earth's weather can be rewritten overnight by forces both natural and human. From the colossal explosions of supervolcanoes to the silent ripple effects of wars and industrial revolutions, our planet's climate has always been a fragile tapestry, vulnerable to the slightest tug of history. And when these events strike, they don't just change the weather, they reshape civilizations. Think about the last time you cancelled plans because of a storm or sweltered through a heat wave. Now imagine living through a year without summer, like millions did after Mount Tambora's eruption in 1815. Or consider the Dust Bowl of the 1930s, when relentless drought and poor farming practices turned America's breadbasket into a wasteland, forcing families to flee their homes. These aren't isolated tragedies, they're stark reminders of how interconnected we are with the atmosphere around us. Weather isn't just background noise, it's a character in humanity's story, capable of toppling empires, birthing new technologies, and even altering the course of evolution itself. In this journey, we'll uncover 10 pivotal moments that didn't just change the forecast, they transformed the world. Some were acts of nature, like the asteroid strike that plunged dinosaurs into eternal winter. Others were human-made, like the nuclear tests that left ghostly fingerprints in the atmosphere. Each event holds clues about our planet's delicate balance and the astonishing power of chance. So brace yourself, we're about to travel through time where ice ages, mega-droughts, and forgotten catastrophes wait to reveal how a single day can bend the skies to its will. The question isn't just what happened, but how these events still whisper to us in every breeze and storm today. April 5, 1815. On a small Indonesian island, the ground convulsed as Mount Tambora unleashed the largest volcanic eruption in recorded history. The explosion was so powerful it could be heard over 1,000 miles away, and the mountain itself collapsed, shrinking by nearly 4,000 feet. But the real devastation didn't come from lava or landslides, it came from the sky. Tambora hurled millions of tons of sulfur dioxide and ash into the stratosphere, where winds carried it across the globe like a poisonous blanket. Sunlight dimmed, temperatures plunged, and by 1816, the world would wake up to a year without summer. Across Europe and North America, frost blackened crops in July. Snow fell in New England during August, and rivers in Germany froze solid under an unrelenting chill. Harvests failed, leading to skyrocketing food prices and violent riots. In Switzerland, desperate families boiled straw and moss just to fill their stomachs. Horses dropped dead in the streets from starvation, and typhus outbreaks spread like wildfire among weakened populations. Governments scrambled to respond, but nature had dealt a blow no policy could undo. This wasn't just bad weather, it was climate catastrophe on a scale no one had imagined possible. Yet in the midst of this darkness, something unexpected bloomed. Trapped indoors by endless rain and cold, a group of writers gathered at Lake Geneva, passing the time by telling ghost stories. Among them was 18-year-old Mary Shelley, who, inspired by the eerie gloom and talk of scientific experiments, penned the first draft of Frankenstein. A tale of creation gone awry, born from a world that felt like it, too, had been abandoned by the sun. Meanwhile, farmers fleeing starvation in New England sparked America's westward expansion, and the invention of the bicycle in Germany offered new ways to navigate a landscape where horses were too scarce to rely on. The year without a summer didn't just leave scars. It reshaped culture, migration, and even technology. It proved how fragile our reliance on stable weather truly is, and how quickly a single event can rewrite human history. Tambora's eruption lasted only days, but its shadow stretched for years, a haunting reminder that the sky, so often taken for granted, holds power over every harvest, every economy, every life below. The Great Plains of America once stretched like an ocean of grass, its deep roots holding the soil steady for centuries. But in the 1930s, that sea of green turned into a swirling nightmare of dust. Years of aggressive plowing had stripped away the natural prairie, leaving the earth exposed and vulnerable. Then the rain stopped. For nearly a decade, drought clamped down on the land, and the winds that once carried the scent of wheat now lifted the very ground into the sky. Dust storms towered miles high, blackening the horizon and choking communities in what became known as the Dust Bowl. Families woke to find their homes buried under dunes of fine, powdery soil. Children walked to school with wet cloths over their faces, while farmers watched helplessly as their fields simply blew away. The storms were so intense they darkened the skies of New York City and even coated ships in the Atlantic Ocean with a thin layer of Midwestern dirt. Crops failed, livestock died, and thousands of desperate families packed what little they could carry onto rickety trucks, joining the exodus west in search of work and survival. These migrants, often called Ockies after the hard-hit state of Oklahoma, became symbols of both human resilience and systemic failure. Yet the Dust Bowl wasn't just a natural disaster, it was a man-made catastrophe. Decades of homesteading and intensive farming had destroyed the native grasses that once anchored the soil. When the drought hit, there was nothing left to hold the earth in place. The very practices that had turned the Great Plains into the nation's breadbasket now reduced it to a barren wasteland. But amid the suffering, something unexpected happened. Science and policy collided to rewrite the future of agriculture. The federal government launched massive soil conservation programs, teaching farmers techniques like crop rotation and contour plowing to prevent erosion. Newly planted windbreaks, rows of trees acting as natural barriers, helped shield the land from relentless winds. Perhaps most importantly, the disaster forced a reckoning with the idea that land was something to be exploited rather than stewarded. The Dust Bowl didn't just change farming, it changed how humanity saw its relationship with the earth. What began as a tragedy became a turning point, proving that even the most devastated landscapes could heal if given the chance. Imagine waking up to find the River Thames frozen solid, not for days but for months, with frost fairs bustling on its icy surface and elephants paraded across the ice to entertain the crowds. This wasn't a freak winter, it was the relentless grip of the Little Ice Age, a climatic shift that held Europe and North America in its icy embrace for nearly 500 years. Starting in the 14th century, temperatures dropped just enough to disrupt the delicate balance of life. Glaciers advanced, swallowing alpine villages. Crops withered under unseasonable frosts, and famines became a grim recurring chapter in history's story. But what caused this chilling transformation? The triggers were as varied as they were devastating. Some scientists point to a dramatic reduction in solar activity, like the Maunder minimum, a period when sunspots all but vanished, dimming the sun's output. Others blame volcanic eruptions, like the colossal blast of Indonesia's Samalas volcano in 1257, which pumped enough ash into the atmosphere to block sunlight globally for years. Ocean currents may have shifted too, with cold meltwater from Greenland's glaciers disrupting the Atlantic's flow. But whatever the cocktail of causes, the effects were undeniable. In Norway, farms that had thrived for centuries were abandoned as snowline crept lower. In Switzerland, entire vineyards vanished under advancing ice. Nowhere was the impact more stark than in Greenland, where Norse settlers had carved out a life for over 400 years. These Vikings, who'd once raised cattle and traded walrus ivory with Europe, suddenly found their world shrinking. As summers grew shorter, hay harvests failed, leaving livestock to starve. Sea ice expanded, cutting off vital trade routes. The Inuit, adept at hunting seals and adapting to the cold, survived, but the Norse, clinging to European farming traditions, faced extinction. By the mid-15th century, their settlements were silent. their fate a warning of what happens when cultures collide with a changing climate. Back in Europe, the Little Ice Age became an invisible hand shaping history's course. During the infamous Year of the Winter in 1709, birds froze mid-flight over France. In 1683, Iceland's population was halved by famine. Even art bore witness. Pieter Bruegel the Elder's snowy landscapes weren't just imaginative, they were documentaries of a world turned white. And then there were the social upheavals. Failed harvests sparked bread riots which fueled revolutions. Some historians argue the frigid winters of the 1780s, which ruined French vineyards and wheat fields, were kindling for the discontent that exploded into the French Revolution. Yet humanity didn't just suffer, it innovated. The Dutch, masters of water management, perfected windmills to drain flooded lands and skated their way into a cultural obsession with ice sports. In England, the Thames Frost Fairs became surreal carnivals of resilience, complete with roasted meat stalls and printing presses churning out keepsakes on the ice. The Little Ice Age forced adaptation, proving that even in the face of a cooling planet, human ingenuity could carve out pockets of warmth. It's a reminder that climate doesn't just dictate our fate, it invites us to rewrite it. The streets of 14th century Europe echoed with a sound more terrifying than war silence. Doors marked with red crosses, corpses piled in carts, and the choking scent of burning herbs filled cities where half the population had vanished. The Black Death wasn't just a pandemic, it was a perfect storm of biology and climate. Between 1347 and 1351, this merciless plague wiped out an estimated one-third of Europe's people. But behind the rats and fleas lay an overlooked culprit, the weather itself. As the Little Ice Age tightened its grip, Europe grew colder and wetter, conditions that turned farmlands into swamps and granaries into buffets for rodents. Grain stored in damp cellars became infested with black rats, whose fleas carried the deadly Yersinia pestis bacterium. Colder winters forced these rats to seek warmth in human homes, creating bridges for disease to leap into crowded medieval towns. Meanwhile, erratic rainfall and failed harvests drove malnourished populations indoors, where close quarters became breeding grounds for contagion. The plague didn't just spread, it thrived, fueled by a climate that had tipped the balance of nature. Some historians argue the Black Death's fury was amplified by a quieter phenomenon, the Great Famine of 1315 to 1317. Years of unrelenting rain and cold had already starved millions, weakening immune systems and destabilizing societies. When the plague arrived decades later, it found a continent still reeling, a reminder that climate disasters rarely strike just once. They stack domino-like, each one priming the next. Yet the pandemic's aftermath reveals an eerie silver lining. With fewer people to farm the land, forests regrew, absorbing carbon dioxide and temporarily cooling the planet further. Wages soared as labor became scarce, and the collapse of feudalism paved the way for modern labor markets. Even fashion changed as survivors abandoned elaborate medieval garb for simpler styles, a pragmatic response to a world that had learned how quickly everything could unravel. The Black Death teaches us that disease isn't just biology, it's ecology. When the weather shifts, it doesn't just rearrange clouds, it rewires entire ecosystems, nudging predators and prey, pathogens and hosts into new and deadly alignments. The fleas that brought Europe to its knees were passengers on a much larger ship, one steered by winds we're only beginning to understand. December 5, 1952. A cold snap settled over London, and residents did what they'd always done, burned more coal to keep warm. But this time, something went horribly wrong. A high-pressure weather system parked itself over the city, trapping the smoke from chimneys, factories, and diesel buses like a lid on a pot. Within hours, a thick, yellowish haze slithered through the streets, so dense that visibility dropped to just a few feet. Buses crawled behind conductors walking ahead with torches. Ambulances stopped running entirely, leaving doctors to reach dying patients on foot. birds dropped mid-flight, suffocated by the toxic air. By the time the smog lifted 5 days later, at least 4,000 people were dead, with some estimates suggesting the true toll reached 12,000. This wasn't just fog, it was poison. The smoke contained lethal concentrations of sulfur dioxide, which mixed with water vapor to form sulfuric acid. People inhaled microscopic droplets that scorched their lungs, leading to pneumonia and brutal asphyxiation. Mortuaries ran out of coffins, and undertakers exhausted their supplies of flowers. Yet what made the Great Smog so shocking wasn't just the scale of the tragedy, but how ordinary it seemed at first. Londoners were used to pea soupers, the sooty fogs that had plagued the city since the Industrial Revolution. They joked about groping their way to work or wiping black grime from their faces. But this was different. This time, the weather had turned routine pollution into a mass killer. The aftermath sparked something unprecedented: political will. Scientists had warned about air pollution for decades, but it took streets choked with corpses to force action. 4 years later, Britain passed the Clean Air Act of 1956, banning coal fires in urban areas and relocating power stations outside cities. The results were dramatic. Sulfur dioxide levels plummeted by 90% over the next 20 years, and by the 1970s, London's notorious fogs were just a memory. But the legacy of the Great Smog rippled far beyond Britain. It became a blueprint for environmental regulation worldwide, inspiring the U.S. Clean Air Act and global efforts to monitor air quality. More subtly, it shifted how societies viewed pollution, not as an unavoidable byproduct of progress, but as a solvable problem. Today, when cities like Beijing or Delhi grapple with hazardous smog, they're fighting a battle London once lost, then won. The tragedy of 1952 proved that even the deadliest weather isn't truly natural when human choices stack the deck, and sometimes it takes a catastrophe to clear the air. The year 536 dawned with a sun that barely shone. Across Europe, Asia, and the Middle East, witnesses described a sky choked by a strange, persistent haze, a veil of dust so thick it dimmed daylight to twilight. For 18 months, the sun cast no shadows, crops withered under unrelenting gloom, and temperatures plummeted. Irish chronicles called it the failure of bread, while Byzantine historians reported frost in August and snow in Mesopotamia. This was the Dust Veil event, a climatic catastrophe so severe it reshaped continents, yet its origins remain one of history's most haunting mysteries. At the heart of the enigma lies a question: what could blanket the entire planet in ash? One leading theory points to a colossal volcanic eruption, possibly from Ilopango in modern-day El Salvador. Ice cores from Greenland and Antarctica show spikes in sulfate deposits around 536, fingerprints of an eruption powerful enough to pump millions of tons of debris into the stratosphere. But Ilopango's timing is debated, and some scientists argue the evidence points instead to a volcano in Iceland or North America. Others propose an even more dramatic culprit, a comet or asteroid impact. Accounts from China mention a thunderous boom in the sky that year, and recent studies of ancient tree rings reveal traces of extraterrestrial metals, hinting at a cosmic collision scattering dust across the globe. The consequences were apocalyptic. In Scandinavia, where summer temperatures dropped by nearly 4 degrees Celsius, entire villages starved. The Eastern Roman Empire, already straining under plague and war, saw grain harvests fail, accelerating its decline. Meanwhile, in Mesoamerica, the Maya city of Teotihuacan may have collapsed partly due to climate chaos, its pyramids abandoned as famine spread. Even nature recoiled. Tree rings from 536 show almost no growth worldwide, as if the planet itself had paused to gasp. Yet the dust veil's true legacy lies in its ripple effects. Some scholars link it to the Justinian plague that erupted a decade later as weakened populations succumbed to disease. Others trace the rise of the Avars and Slavs in Europe to power vacuums left by fractured societies. And in Ireland, the catastrophe may have inspired the legend of Fimbulwinter, a Norse myth about endless winter heralding the end of days. What began as a climatic anomaly became a cultural spectre, a ghost in the machinery of civilizations. Perhaps the most unsettling lesson of 536 is how swiftly the familiar can unravel. Unlike slow-moving droughts or predictable monsoons, the dust veil struck without warning, proving that our reliance on stable weather is a gamble against forces far beyond human control. Today, as scientists drill ice cores and scour ancient texts for clues, the event stands as a cautionary tale, a reminder that the sky, so often silent, can whisper warnings in the language of dust. The chimneys of 19th century Britain didn't just spew smoke, they rewrote the rules of the atmosphere itself. As the Industrial Revolution roared to life, coal-powered factories and steam engines transformed more than economies. They altered the very chemistry of the air. For the first time in Earth's history, humans were digging up carbon stored underground for millions of years and burning it on a colossal scale, flooding the skies with invisible heat-trapping gases. But here's the twist: scientists sounded the alarm almost immediately. In 1824, French physicist Joseph Fourier calculated that Earth should be far colder than it was, theorizing that something in the atmosphere acted like a blanket, a concept we now call the greenhouse effect. By 1856, American scientist Eunice Newton Foote went further, demonstrating that carbon dioxide trapped heat more effectively than other gases. She warned that an atmosphere richer in CO2 would result in a warmer planet. Her findings were met with polite applause and then filed away. Industrialists dismissed such concerns as irrelevant to progress, while the public marveled at locomotives and blast furnaces, unaware they were witnessing the dawn of an unintended experiment with the global climate. The scale of change was staggering. Cities like Manchester and Pittsburgh became cloaked in perpetual soot, their residents coughing through air thick with sulfur. Forests fell to feed furnaces and railways, stripping the land of natural carbon sponges. Even the oceans bore the brunt, as increased CO2 began acidifying seawater, a phenomenon that wouldn't be measured for another century. Yet the most insidious effect was invisible. Year by year, the concentration of carbon dioxide in the atmosphere crept upward, from around 280 parts per million in pre-industrial times to nearly 300 by 1900. A tiny shift with monumental consequences. What's striking isn't just the transformation, but the resistance to acknowledging it. In 1896, Swedish chemist Svante Arrhenius published groundbreaking calculations linking coal burning to future global warming. He speculated that doubling CO2 levels could raise temperatures by several degrees, a prediction hauntingly close to modern models. Yet even he saw it as a distant problem, musing that it might take 3,000 years. The world shrugged and stoked more furnaces. The Industrial Revolution didn't just invent modernity, it locked in a paradox. The same innovations that lifted millions from poverty also set a climatic time bomb ticking, one we're still learning to defuse. Early warnings were there, buried in scientific papers and overlooked in the rush toward progress. Today, as we grapple with wildfires, superstorms, and rising seas, we're living in the shadow of choices made when coal was king and the sky seemed too vast to change. The lesson: climate shifts don't announce themselves with fanfare. They whisper in data, smoke, and hindsight. June 15, 1991. In the Philippines, Mount Pinatubo, a volcano that had slumbered for over 600 years, woke with a fury that would echo through the atmosphere. Its eruption blasted 12 cubic miles of rock and ash into the sky, along with 20 million tons of sulfur dioxide. That gas did something extraordinary. It combined with water vapor to form tiny reflective particles called aerosols, creating a massive sun shield in the stratosphere. Within weeks, these particles spread across the globe, scattering sunlight back into space. The result, Earth's average temperature dropped by nearly 1 degree Fahrenheit over the next 2 years, a staggering shift for such a short time. Scientists had long theorized that volcanoes could cool the planet, but Pinatubo offered something rare, a real-time experiment. Satellites tracked the aerosol spread, while weather stations recorded the dip in temperatures. Crops in the American Midwest struggled under muted sunlight, and monsoon patterns shifted dramatically in Africa and Asia. Even the ozone layer took a hit as the aerosols accelerated chemical reactions that destroyed protective ozone molecules. For climate researchers, it was a bittersweet breakthrough, a tragedy for those near the volcano, but an undeniable confirmation of how delicate Earth's climate system truly is. The eruption also ignited a fiery debate. If nature could cool the planet with aerosols, could humans mimic the effect to combat global warming? Geoengineering proposals that once seemed like science fiction suddenly had hard data to back them up. Advocates pointed to Pinatubo's cooling as proof that injecting sulfur into the stratosphere might buy time against rising temperatures. Critics fired back with warnings: the ozone damage, disrupted rainfall, and the ethical quagmire of playing God with the atmosphere. Pinatubo's legacy is a paradox, a disaster that advanced science, a natural event that reshaped human ambitions. It revealed both the power and peril of tampering with Earth systems, leaving us with a question as hazy as its ash-filled skies. If we can engineer the climate, does that mean we should? The volcano didn't just change the weather, it forced us to confront how far we're willing to go to control it. The Sahel stretches like a parched ribbon across Africa, a fragile transition zone between the Sahara's sands and the continent's lush tropics. For centuries, its people mastered the art of survival in this marginal land until the 1970s, when the rains vanished. What began as a typical dry season spiraled into a catastrophe lasting nearly 2 decades, with rainfall dropping by 40% in some areas. Crops withered, wells ran dry, and an estimated 100,000 people starved to death. But this wasn't just bad luck, it was a collision of climate shifts and human choices that turned a drought into a humanitarian nightmare. Scientists later traced the crisis to a chain reaction in the atmosphere. Warmer sea surface temperatures in the Atlantic had pushed the intertropical convergence zone, the rain-bearing wind system, farther south, leaving the Sahel high and dry. Yet nature wasn't the only culprit. Decades of overgrazing by livestock and rampant deforestation for firewood had stripped the land of vegetation, exposing the soil to relentless winds. Without roots to anchor it, the earth turned to dust, reflecting more sunlight and further suppressing rainfall. It was a vicious cycle. Less grass led to less rain, which led to even less grass. Traditional nomadic herders, who'd once moved with the seasons to prevent overuse, found their ancient routes blocked by newly drawn national borders, forcing herds to stay put and accelerating the land's collapse. The human toll was staggering. In Niger, families boiled leaves and ate dirt to fill their stomachs. Ethiopia became synonymous with famine, its emaciated children broadcast into living rooms worldwide. But the drought's aftershocks went deeper than hunger. As resources vanished, tensions flared between farmers and herders competing for scraps of arable land. In Chad and Sudan, skirmishes over water and grazing rights escalated into full-blown conflicts, foreshadowing the climate wars of the 21st century. Meanwhile, aid agencies scrambled to respond, airlifting sacks of grain while grappling with a grim reality. Emergency food drops couldn't fix broken ecosystems. Yet amid the suffering, glimmers of innovation emerged. Farmers began experimenting with pits, small holes dug to concentrate rainwater around crop roots, while projects like Niger's Great Green Wall aimed to restore vegetation belts to hold back the desert. International researchers studying the Sahel's plight coined the term desertification, forcing the world to confront how human activity could amplify natural disasters. Slowly, painfully, the region became a living laboratory for resilience. proving that even the most degraded landscapes could heal with time and care. The Sahel drought didn't just change the weather, it exposed the thin line between survival and collapse in an interconnected world. Decades later, as climate change tightens its grip, the lessons of the 1970s echo louder than ever. When the land suffers, so do we. But the Sahel also teaches us that despair isn't inevitable, that even in the harshest conditions, life finds a way to claw back. In 1983, a group of scientists sat down to calculate an unexpected side effect of nuclear war, one far deadlier than radiation or blast waves. Their findings, published under the ominous title Nuclear Winter, suggested that even a limited exchange of atomic bombs could plunge the planet into a decade of darkness and cold. The theory was simple but terrifying. Firestorms from burning cities would loft millions of tons of soot into the stratosphere, blocking sunlight like a volcanic eruption on steroids. Global temperatures might drop by 20 degrees Celsius, enough to kill crops, collapse ecosystems, and starve survivors in a world already shattered by war. What began as a climate model became one of the Cold War's most potent warnings, proving that the weather itself could be a weapon of mass destruction. The research team, led by Carl Sagan and Richard Turco, didn't set out to frighten the world. They were building on volcanic data, including the cooling effects of Mount Tambora and Krakatoa. But their models revealed something darker. While volcanoes spew reflective sulfates that eventually rain out, nuclear fires would create tiny, rugged soot particles that linger for years. Even a war using less than 1% of the world's nuclear arsenal, say 100 Hiroshima-sized bombs, might trigger agricultural failures from Iowa to India. The Arctic could freeze over permanently, while tropical monsoons would falter, turning rainforests to tinderboxes. And this wasn't speculative fiction. Declassified documents later showed Soviet scientists had reached eerily similar conclusions in secret. Politically, the nuclear winter hypothesis struck like a thunderclap. Arms control advocates seized on it as proof that no one could win a nuclear exchange, while military strategists bristled at the implication that their war plans amounted to planetary suicide. President Reagan privately confessed the idea shook him, and Soviet leader Mikhail Gorbachev cited it as motivation for disarmament talks. For the first time, the doomsday clock wasn't just ticking toward annihilation. It was warning of a slow, silent asphyxiation by climate. Yet the theory also sparked fierce debate. Critics argued the models overstated soot injection or underestimated atmospheric cleansing. Some accused Sagan of activism disguised as science, while others countered that erring on the side of caution was the only moral choice. Decades later, refined climate models confirmed the basic premise, though with slightly less extreme cooling. The truth landed somewhere in the middle. Nuclear winter might not last 10 years, but even a 3-year chill could kill billions through famine. What lingers isn't just the science, but the cultural aftershocks. Films like The Day After and books like On the Beach suddenly had a new layer of horror to depict. The theory forced humanity to confront an uncomfortable truth. Our greatest existential threat wasn't just bombs, but the fragility of the systems that keep us fed and warm. Today, as nuclear tensions simmer anew, nuclear winter remains the ultimate cautionary tale, a reminder that war doesn't just destroy cities, it rewrites the sky. From the ash-choked skies of Mount Tambora to the radioactive fears of nuclear winter, these 10 events reveal a truth as old as civilization itself. Weather isn't just something we live with, it's something we live by. The year without a summer didn't just freeze crops, it birthed Gothic literature. The Dust Bowl wasn't merely a drought, it rewrote America's relationship with the land. And the Industrial Revolution's smokestacks didn't just power factories, they set in motion a climate experiment we're still struggling to control. Each of these moments, whether born from volcanoes, human folly, or cosmic accidents, proves how tightly the fate of societies is stitched to the whims of the atmosphere. But here's the deeper thread: these events are never isolated. The Little Ice Age's chill may have begun with a volcanic eruption, but it snowballed into revolutions. The Black Death spread was accelerated by famine, which itself was fueled by shifting rains. Even the Sahel's suffering wasn't just about missing monsoons. It was about borders, overgrazing, and the fragile dance between human choices and natural systems. Climate disasters don't just happen to us, they mirror our decisions back at us, magnified by time and consequence. Today, we stand at another inflection point. The same power that once accidentally cooled the planet with smog now lets us see these patterns unfolding in real time. Satellites track wildfires, models predict monsoons, and yet the challenge remains. Will we heed the warnings buried in ice cores and tree rings? Will we learn from the civilizations that collapsed under drought, or the societies that adapted, like the Dutch mastering water or Sahel farmers digging zai pits? The past isn't just a record, it's a roadmap painted in dust storms and frost fairs. So here's the question these events leave us with. What will future historians say about our chapter in this story? Will they marvel at how we steered away from disaster, or mourn another civilization undone by a sky it took for granted? The weather doesn't care about borders or politics, but it responds relentlessly to what we do. And if history teaches us anything, it's that the next climate-altering event might not come from a volcano or a war, but from the choices we're making right now. Want to explore more mysteries where history and nature collide? Stick around, there's always another storm brewing just over the horizon.